Hi there, IB Physics students. I'm Ramin Farhangi and I welcome you to the introduction to my lectures, my video lectures on which I will focus on the essential things you will need to review for the IB Physics course and succeed in the exam so that we can put a stamp on your face and you can get to college. So let's start with a brief history of how gravity was discovered as a way to illustrate what physicists do in general. So first, physicists are good thinkers. They do their best to visualize what kind of juggling games the universe is playing. In fact, there was a time during which physicists believed that this was the only thing you needed to do. You just needed to sit and think about it. At around 350 years before Christ, this man, Aristotle, sat and thought about a problem. He questioned, imagine that I have a small mass and a very big mass. Let's say something that's 5 kilos versus something that's 100 grams, and I drop them. And after a certain time, while they're freely falling towards the ground, I record their speed. And he thought, well, it seems reasonable that the speed of the small object, the less massive object, will be much smaller than the speed of the massive object. Aristotle's problem is that he was only a thinker. He thought you could just sit and think about it, and he didn't think of doing experiments. And that's the second thing a physicist does. He not only tries to visualize a problem, but he also does an experiment to check it out, to see what happens. We had to wait almost 2,000 years until 1586, when an experimenter called Simon Stevin finally tested Aristotle's hypothesis in reality and disproved it by throwing different masses from the top of the Tower of Delft. Popular accounts give credit to Galileo for performing this experiment from the top of the Tower of Pisa, even though the evidence is limited to one of his pupils' biography. Even at that time, engaging in any scientific investigation or reasoning was quite dangerous, and it could get you burned alive by the Inquisition, as done to Giordano Bruno in 1600, for arguing relentlessly that other worlds exist beyond the solar system and that the night sky is not just a dome with little Christmas lights. 33 years after Bruno's execution, Galileo preferred to deny the heliocentric model when threatened to be tortured, and he was put under house arrest until the end of his life. So at that point, we had an experiment that disproved the hypothesis of Aristotle that survived for nearly 2,000 years, and it was made obvious that a physicist needs both to think and to experiment to fuel an understanding, a deep understanding of the juggling game that the universe is playing. Now let's talk about this man, Isaac Newton, recognized as being the most impactful physicist of all times, whose discoveries had a lot to do with enabling the Industrial Revolution to happen at all, in fact. Well, Isaac Newton, while he was sitting under a tree far away from London, where the plague was nearly killing everyone, he asked himself the question, well, this apple that's falling towards the ground, is the force that's applied to this apple the same as the one that's applied to the moon? And I think you can clearly salute the intuition here. I mean, personally, I think that this is one of the most beautiful questions ever asked. This apple is affected by Earth. Apparently, the moon turns around the Earth, so it's also affected by Earth in some way, and they both seem to be experiencing a force that attracts them towards Earth. Well, is this force of a similar nature between the apple and the moon? I want to say, wow, what a question. And eventually, this question led Newton to discover the universal law of gravitation, a law that says that any two masses in the universe attract each other with a force that we can call the gravitational force, and it depends on the masses and the distance between these two masses. And finally, he even found a mathematical relationship between all the variables of this system, that the gravitational force between the two masses is equal to some constant times the product of the two masses divided by the square of the distance separating these two masses. And in the end, this story perfectly illustrates what physics is all about. First, questioning the relationship between different variables, having misconceptions and making mistakes, experimenting to prove or disprove some theory, asking some new questions and digging deep into the fundamental nature of the universe to find, finally, the correct relationship between the variables of a system. And the goal of the IB Physics course is to make you live this very process.